I'm Meredith Blackwell, and I am interviewing Dr. Salomon Bartnicki-Garcia, a person who has been associated with the Mycological Society of America for many years and is one of our eminent, distinguished mycologists. And he now lives in Ensenada,
Baja
in
California.
Baja California. And he lives on the Sea of Cortez, no doubt, in a fancy house.
Now the Sea of
No?
Cortez is far away, but the Pacific
Oh,
is
the
right there.
Pacific.
We have it
Okay.
only 3 feet away.
Okay, so what I want to know is, where were you born?
I was born in Mexico City
Oh,
at a glorious time when Mexico City was at its very best. And guess what?
what?
We didn't realize it.
Yeah, that's always the
We
way it
didn't
is.
realize how good it was then. And then it became a monster of a city.
Yeah, I've been there, but it was like 30 years ago.
Yeah, no, it's still the center of culture for Mexico. I mean,
Yeah.
that's
It
why
was-
Mexicans like to stay in Mexico City because
It was a wonderful city. I loved it.
It's like New Yorkers, you know, they cannot get away from New York
Yeah.
because it's the center of the universe.
Yeah. Well, I went all over Mexico City in a Volkswagen Bug, and all over Mexico, actually.
Yeah, oh, good.
Yeah, from Zacatecas, further north, Saltillo, Zacatecas, Guadalajara, Morelia.
Oh, that's the real Mexico.
And then we went around to Puebla and
Unlike
Oaxaca.
the people that visit Mexico by going through Tijuana and
Yeah.
that's it.
Well, we went there too, but we went all over.
Yeah.
It was really wonderful in those days.
Yeah.
So anyway, so you were born in Mexico City and you lived there for a long time? Did you go to...
I lived there. All my studies were in Mexico
UNAM?
City. No.
Where?
UNAM was the enemy.
Okay,
we were at the Polytechnic.
Okay. Yeah, I
Yeah.
visited there. A professor
Yes.
from Poland, Rosinski?
Oh,
botanist.
Rendowski.
Rendowski, yeah.
Yeah, he was. Now in biology and microbiology, we were very strong. The university was concentrating mostly on law, humanities,
Right.
but a career in science, you know, was much better at the Polytechnic.
What about, they're being a little noisy. What about, were there mycologists there or not?
No. In fact, my introduction to mycology was by taking a course in medical mycology. It was part of the courses we had a 5-year fixed set of courses, and
That's
one of
for
them.
an undergraduate degree?
Yeah, for the
Yeah.
undergrad. Well, it was more than it was a fancy undergraduate
Okay.
because it required a thesis, a research thesis.
Okay.
And so I had mycology from a medical biologist, and I had my research training from Casas Campillo. Casas Campillo was a microbiologist at Syntex. Syntex was the place where the pill was invented. Yeah.
Birth control pill.
Yeah,
Okay.
they were great in all the cortisone steroid research, and he was a microbiologist in there. As you maybe you know, maybe you don't. The synthesis of cortisone require a very difficult step that only Rhizopus could do it. The organic chemists have a
The fungus saved it.
The fungus saved it. Yeah, so that was his.
Yeah.
So in the afternoons after work, he went to the school to take care of a research lab, and we had a good group, about a dozen students there.
Was Guzman there?
Gaston was in the same institute, but in a different department.
But
yeah.
at the same time?
Yeah.
Yeah.
See, Gaston was never interested in microbiology.
As you were.
He was interested in the macro
Yeah.
mycetes.
Yeah. So I guess then then you went to.
So, well, but at that time in Mexico, there were no doctoral programs. So the only solution was to go abroad, and Casas Campillo had established a good rapport with Selman Waxman. I don't know, you remember?
Yeah, oh, no.
Yeah, and Selman Waxman had just, built this fabulous research center in Rutgers. And I was accepted there, and I spent my 4 years of doctoral studies there under Walter Nickerson. I don't know if you ever met Nickerson.
Is he still there? Or
No way, he died then.
Okay, well, there's a man there now that has established a little museum in a room to Waxman. It's a room like maybe a small classroom, and it's been gutted, and they have all this Waxman stuff in there. I visited a few years ago.
Yeah.
It was interesting.
No, that didn't exist when I was there.
No, it was more
Waxman
recent.
was still alive, I
Yeah.
yeah.
Yeah. Well, this man wants to be sure that his memory is there at Rutgers. You know, I have a student at Rutgers in the botany and plant pathology. I'm not sure what the department's called now. Yeah, so what did you do at Rutgers?
At Rutgers, I did my PhD work,
With walls, fungal walls at that time?
Well, at that time, Nickerson was convinced that to understand morphogenesis, you have to understand the chemistry of the cell wall. So, but he assigned me a project to study dimorphism. He had heard that mucors may be dimorphic.
Yeah.
So I went there to the collection of bugs at the institute, and I got several mucor strains, and I tested it, and I discovered that with the help of carbon dioxide, we could switch the fungus, the mycelium, very mycelia-like fungus, to a perfectly yeast,
And that's a very famous lab exercise now.
Yeah.
To show that conversion.
Yeah, we published it as an exercise at ASM years later.
Yeah.
So
and I think you just stab. You don't have to use the carbon dioxide.
But what he wanted, since I had conquered the dimorphism of the fungus, what he wanted to know is are there any differences in chemical composition between the walls of those two? Because that was his basic premise. So I had to, basically discover methods to isolate cell walls. It wasn't easy. There was no methodology at that time. To break tough cell walls. Yeah. And eventually, I was able to make preparations of pure walls of the mycelium and pure walls of the yeast. And you should have seen his face when I show him the vials with white stuff, powder, purified, under the microscope they were very clean. So then there was the chemistry, paper chromatography. That was the latest thing. No mass spectrometry. There was no liquid chromatography. We had paper chromatography. So that was very good. That was I think a seminal paper for future studies on cell wall.
And you found big differences.
I found one difference in manner and composition, but that was not enough to explain. At the end, by studying the Phytophthora and the cell walls and the life cycle of Phytophthora, found out that the wall composition is the same, and the morphology changes a lot. So it wasn't the chemistry of the wall.
But from mucor?
From mucor, it was a difference, but I don't think you could explain it. No.
Okay.
It's actually later we discovered it's the way the wall is made. You see.
And in the layers.
Yeah. When I was hired by the plant pathology department and at UC Riverside, one of the projects that we had was to label the cells with radioisotopes. So to look where exactly is the wall made in the fungus. And that was really a very important paper, because we could see that the wall in the hypha is made at the very tip. In fact, you can graph the number of silver grains and find a very sharp gradient of synthesis concentrated at the very tip. Now, we didn't know why. I mean, it was really a mystery. How could a fungus concentrate all of its wall synthesis at the very tip? Because there was nothing known about the inside of the fungus. It was until, the electron microscopists, Bracker and Girbard and others, discovered that it was a collection of vesicles that reached at the very tip and discharged the enzymes that make the wall. So that was a nice connection between the biochemistry and the electron microscopy, which was the strongest areas for us in fungal physiology at that time.
Yeah.
Combination of biochemistry and electron microscopy. Then that changed with time, but at least for a couple of decades, that was the...
Yeah, because I got to do some electron microscopy before things weren't all looked at. And it was so exciting to see the inside. Yeah, so did you do this after your degree or during, before, after, during?
During my degree, yes, we did the electron microscopy comparing the mycelial and the yeast cells. I didn't do the microscopy. We had a technician. My electron microscopy was a new thing in there.
Yeah.
I mean, and this woman wouldn't even let us touch the microscope.
We had a person like that at Texas. Well, he trained us, but he was an ex-Nazi.
Yeah.
And he ran the place like that. It was very tough. Yeah. So did you get hired easily after you got this elegant study done?
Well, I was hired. These are some of the things that happen by miracle or accident or whatever.
Luck. That's our theme, luck.
It's luck. It was once I gave a big lecture, and the subject was luck. through my entire life is luck.
Yeah.
And what happened? There were very few opportunities for me, and at UC Riverside in the plant pathology department, they were looking. The plant pathology department was changing. They didn't want to be all just field pathologists. They wanted to have, fundamental, basic researchers.
Someone to look inside the fungus.
Yeah.
Or tell what was going on.
So they were looking for somebody trained in, fungal physiology. At that time, that was the word, fungal physiology. And the search committee, this is interesting. One of the members of the search committee decided to approach Rutgers. They told them, no, there's nobody at Rutgers. Why? Don't bother. But he said he went against the committee and wrote to Rutgers. And at that time, I was on a postdoctoral fellowship.
But not at Rutgers, or were you at Rutgers?
At Rutgers,
still?
yeah.
You still were.
So I got, the Professor Starkey gave me the letter, and I applied. And listen, I couldn't have had a better job than that.
Riverside?
Not really. It was ideal. It was a strong plant pathology department, with plenty of resources. Not only that, in no time I got an NIH grant.
That's a big step.
To the surprise of some of my plant pathology colleagues who have depended on state support all along, or commodity money. So getting those first NIH grants were decisive, because the equipment is expensive and the reagents and all that. So, and when NSF opened, before that, after a few years, I was doing already phytophthora research, And I decided to send a project on Phytophthora, and they swallowed it. NIH. They never bothered to ask if it's a medical pathogen or what. So I was supported by both NIH and later NSF. So I had good support at the beginning, and it wasn't that difficult. It's not like today,
Yeah,
you know.
it's hard today.
So I was very lucky in that respect, you know, to have a strong start. With time, getting support became more and more difficult. You know, it's just the reverse. The more you can show in productivity, the fewer your chances of getting money.
So you had joint appointments for a while, Riverside and Ensenada? No?
No. No, and
You just had two addresses.
I did 38 years of professorship in Riverside, and in the year 2000, I migrated to Mexico, and again I was another good piece of luck. The funding, the NSF of Mexico, CONACYT, which was an agency to support research. When I finished my PhD, there was nobody. But in the year 2000, there was big CONACYT, and I approached them and I said, well, I want to return to Mexico. I said, I don't want to just return to continue research. I want to return to set up a department to give opportunities to young researchers. That was my proposal. So I talked them into giving me $1 million to set up the lab. And that's why, one of the purchases we made was extremely useful. That was a confocal microscope. When confocal microscopy was just beginning in the year 2000. And with that microscope, these young women that we hired, they went crazy using it. They just loved it. So they have utilized the confocal microscopy, plus doing all this, making mutants of Neurospora, most of them, so that you can label exactly the molecule you want with fluorescent GFP. And they got fantastic results in that. But for that, I just take indirect credit.
Well, I've seen some of those pictures. They're just beautiful.
No, they are.
Beautiful.
They are. So
Yeah.
it's a double skill. The skill of knowing how to use the microscope, because you can still see the publications, terrible microscopy, really, even elementary microscopy, light microscopy, terrible images.
But they did the microscopy and they knew the fungi too, or the organisms.
No, and they do the molecular, because Marichel Riquelme, she spent 3 years at Oxford, after she graduated from Riverside.
Yeah, Kathy Aim, who's here from Purdue, they were there together in Lorna Castleberry's lab, I think.
Yeah. So that...
Castleton.
Yeah, with Castleton, they had a... So that was very, very useful, because I could not have taught her molecular genetics. It wasn't my field. I was trained and brought up as a biochemist, a microbiologist, and I never liked genetics. I don't know if you remember this little book by Catchicide, Fungal Genetics.
By whom?
Catchicide.
No, I never used that.
It was the most boring thing. I mean, they were just making crosses, and it just you have to have a liking for things. You have to have a liking for microscopy. You have to have a liking for biochemistry. You have to have a liking for mathematics. That was in my later years. I decided that we needed to understand the mathematics of the growth process, and I was able to to talk a young mathematician from the mathematics department in Riverside to collaborate. And that's how we developed a model to explain the growth of a hyphae. And that has been relatively successful model. But because it's mathematical, you know, biologists have a difficult time swallowing. They like genes.
Not the modern biologists.
Yeah.
That's the coming thing, or it's already come to be mathematical.
Yeah, but
Yeah.
so over the years, you know, I have migrated from. We were in my first years were with the Microbiological Society, ASM. That's how we had the interaction. We had a nice group of fungal physiologists and biochemists in the ASM. The Mycological Society was a disaster. I don't know if you remember how bad it was that was maybe before your time.
It was probably before my time, although when I joined up, there was a bunch of white guys in suits that ruled.
White guys in
Yeah, they wore suits to all the meetings. And
Trump-like.
yeah, well.
No,
Anyway.
it was. I remember that one year they didn't even publish the journal. They were so.
Oh gosh, I remember hearing about that.
Yeah, they were disorganized. That was bad.
Well, it was one man, and they had to send
Yeah.
someone from Syracuse University to rescue the journal, I heard.
Yeah, no, it was. Do you know what rescued really the field? Were the British mycologists. The
Did they?
British mycologists were, you know, in my area, they were decisive in promoting science, mycology, fungal biology, which we now call it, really.
Yep.
And that we owe it to them. They're a very strong group. I was invited to Britain many times in my younger years when it's important, really.
Yeah.
So I had good interaction with the British mycologists, yeah, and they were very strong. And well, over the years, we reverted back to the Mycological Society. You know, what happened at ASM is that the medical mycologists took over, the clinicians, and they didn't want to hear about fungal growth and morphogenesis. They wanted to hear medical stuff.
Yeah.
So the interest of the society changed, and we also moved. So we've been associated strongly with the Mycological Society since let's say since the mid-70s, I think.
Yeah, I can remember you coming to meetings with a young woman, and she had all of this equipment she would bring, like a big box or something.
Oh, that probably is Bracker's technician.
Oh,
Yeah,
I thought you were involved.
No?
No?
No.
Okay. So I have a photograph of you and Bracker, and you're standing back to back.
Back to back. Oh, yeah. That's a we have a poster.
Do you have that?
Oh, yes.
I love that picture.
That was, yeah.
I think it was a poster for MSA that
Yeah.
was never printed, but by me. You may have printed one.
No,
But it said, join MSA, measure to measure or something.
So thank you for that. I thank
The
you.
measure of a distinguished mycologist, because you were both distinguished mycologists.
Yeah, well, in those years, what Bracker was doing was greatly appreciated. I mean, although he was considered a terror of and students stayed away from his
Yeah,
lab.
because he didn't have very many students.
No.
No.
But for us, you know, the association with Charles Bracker was decisive. He was very good. And he ended up, sadly, really bad.
Yeah.
Even his department at Purdue turned against him, and they closed his lab, and physically he was miserable.
Well, I didn't know it until after he died, but there were a lot of things he did. He had an orchid collection.
Yeah.
Interested in orchids.
He switched completely from fungi to orchids, and that was basically to honor his wife, because
that's right.
it was so sad. His wife was very strong, and we all believed that she was going to outlive him, really. But in the end, pancreatic cancer
Right away.
took her life very quickly. They had plans to come to buy a house in Santa Barbara and come and retire. He liked Santa Barbara, and that went bad, and then ruined the rest of his life. It's really sad.
So, do you go into work every day?
Yeah, but I'm stopping.
Really? You had enough?
No, I physically, I would love to be connected, They said I can keep my office and all the other things, but all the other little privileges. But there's no way I can deliver an 8-hour performance.
Well, but you're a good resource for young kids.
No, I know.
But,
No, I think it's important, because one of the things I did when I hired my group of researchers, well, first of all, they were going to be independent. I made suggestions. The only condition is we want to work on fungi. This department is dedicated to the study of fungi, and we're going to start with basic research, and later we will do applied research. But first, we're going to get strong in basic research, and Rosa Mourinho chose to do a cytoskeleton with a microscope, and Marichelle did the chitin synthesis. So each one, and another one who's not here, Ernestina Castro. I connected her with Stuart Brody. You know him?
Yeah, I remember him.
Yeah, Stuart Brody, who has been working on rhythm, circadian rhythm. So we did some work on circadian rhythm, but then she found that it was a tough group, very competitive, and Jade Dunlop and company. You can't succeed when you have you're against strong competition.
Yeah, I've never worked on things that other people were working on. It was much easier that way. More fun.
No,
it is. You didn't have to speed all the time.
Yeah, in the last years, almost all the entire work from the department has been on Neurospora, simply because of the two things. The facility to make mutants and the size of the cell, it lends itself to microscopy. Those guys with aspergillus and schizophyllum, they have tiny little hyphae. We have big hyphae.
Well, at LSU, we tried to find somebody with electron microscopy skills, and it's a very difficult thing to find these days.
Yeah, because you see, I bought 2 pieces of equipment, the confocal microscope and an electron microscope. The electron microscope, the people that we tried to hire turned us down. So, and it was very difficult to find somebody. It's still there. Robbie Robertson has been very helpful to us, but we need somebody like Robertson to be in charge of the electron microscopy research, not just the technical part, but the research part. And it's such a needed tool. Confocal microscopy could take you this far, but then you start asking, well, what's behind all those colors? What is it? You need electron microscopy.
There's nothing like transmission.
Yeah, so. and that requires a lot of skill.
It does.
And Robertson was well trained, and
where did he go to school? I can't remember. Do you know?
Georgia.
Georgia, that's right, of course.
No, Georgia was, in my days, the groups that were strong were the ones in Georgia and Purdue. At Purdue, we had Jim Lovett.
Right.
They're all disappearing. I mean,
Yeah.
I feel lonely now.
Well,
At Georgia, there was Mel Fuller.
Right.
I think he's still alive.
He is.
Mel Fuller, and he had
Mel walked away from mycology. He lives in Maine.
yeah. No, he was very strong. He did a lot of good in that department.
He had many students.
It was strong department of.
Yeah.
In fact, we had meetings there, mycological meetings in Georgia, in Athens. Yeah.
I've been to 2 meetings there at least,
Yeah.
maybe 3.
Yeah.
Yeah. I remember Ralph Emerson was ill, very ill, but they had already planned a symposium or a workshop in his honor. I remember going to that there. And a lot of Mel's students who were electron microscopists, they knew how to time all the fungi in their life cycle because they were doing that for microscopy. So it was a really good workshop because we had everything at the perfect stage. Yeah. So
here we are.
So do you have family in Ensenada or?
Yeah, well, no, there were 6 of us, you know, 3 brothers, 3 sisters, and we are all spread out. Only my younger sister is in Mexico City.
Oh, okay.
The rest are somewhere else, and I'm the only one in science.
Oh. That's like my family. I only have one brother.
It's really. I like to emphasize the Garcia part of my name because Garcia is my mother, okay?
Right.
And my, the impulse that my mother gave me, it was decisive. She had great, she was very ambitious, and she transferred the ambition onto me to reach the sky and to love nature and all that. That was very decisive to have, even though she hardly finished primary school. Anyway, she had this the conviction that you needed to have a university degree and to be anybody, you know.
My father's family was that way. His mother had gone maybe to 8th grade, his father to 3rd grade. And they insisted all their kids go to college, 6 kids.
Yeah. The good thing is that all my education was free, really. They didn't have to pay for it.
Oh.
And that was...
When you got to grad school or earlier too?
Well, even to graduate school. I came to the U.S. with a grant from the State Department, a 1-year grant. And then Nickerson supported me for the rest of my stay. So anyway, and tuition in Mexico is almost non-existent. The education was free.
Wow.
And we had good teachers. Mexico had there was something incredible happening in the 1930s. The war in Spain destroyed that country, you know.
Yeah.
And intellectuals were persecuted. Really, the Franco regime was brutal, and the intellectuals ran away from were killed or ran away. And the Mexican president at that time decided to send ships to France to collect the intellectuals in all areas. So many of my professors were Spanish. So we took the very best of an entire country and brought it to Mexico. And with that, think of it. It's almost a renaissance, an intellectual renaissance for a country. To take away the very best of another country and absorb it.
How is it today?
Well, today they're probably gone. there is only the remnants of the good deeds that they did.
But they still have students who have survived and come on down till now?
No,
Not really.
you know, most of the Spaniards that came as in the exile thought they were going to go back because that they would have, you know, Franco would not live long.
Yeah.
Well, Franco
Lived long.
stayed in the 1970s. So they became Mexicans. They just absorbed. But the U.S. also benefit the same, you know. Well, if Hitler had not persecuted Jews, think of all the scientists that benefited this country, you know.
We wouldn't have had so many bombs. Anyway.
Yeah.
You never know.
You never know.
So, any big mistakes you made? Doesn't sound like it.
Yeah. I'll tell you one.
What?
One mistake. I started from the very beginning collecting literature, okay?
Yeah.
I had punch cards. Do you ever have?
I didn't do them, but I remember.
You type, even they would type all the information on the card and then punch it accordingly to subject and all that. Then punch your needle, shake it.
And you would pick up all the right ones. And you spent too much time doing that.
That was, well, that finally became impractical, so we abandoned. So but collecting reprints, you know, writing every time. And then came, remember current contents?
Yep.
That's the way, you know, that miserable task of going through current contents and identifying papers and sending the little cards, and then most of them responded. So over the years, I collected thousands and thousands of reprints. And I said, I'm on top of everybody because I will have the best collection of literature on fungal biology. And you know who ruined me?
Who?
Google.
Google.
Because,
Computers and Google.
Because everybody, well, I have originals, okay? You may think that's valuable, that they're originals.
Yeah.
But by now, most of the literature has been digitized. So you can access it through Google.
Well, 3 years ago, I retired from LSU. And so I talked to the people there that took care of the trash and all. And they brought a big recycling bin. Oh, it was huge. It was as big as those doors over there. And they put it out by the loading dock, and I hired 2 kids, all my journals, all my reprints. They went in those recycling boxes. And
bye-bye.
Bye-bye. It was sad, but I thought, no, I'm moving. I've got to get rid of them. But the only mistake I made, mycotaxon, and I do occasionally have something in that, but it was not, it's not online very well, so that was the problem. You had enough?
Yeah, but you see, collecting all those reprints, and because once computers became available, all that information was put in into a computer.
Yeah.
So that you can access it. Otherwise, you just have piles of papers. So I have my collection, you know, the titles digitized, so I know where they are and they're numbered. I got a numbering system. I know where they are. It was a major investment in time, but in the end, it wasn't worth it.
Well, but it probably was useful for a while.
So I have 10 filing cabinets full of reprints. I didn't throw them away like you.
I had no place to put them.
Well, we bought a shack from Sears.
Oh, how often do you go back there and look at them?
Well, once in a while, because
you do actually use them.
Most of the time you can get it from through Google.
Yeah.
So it's it's well, that I would say was a a mistake.
That was your only mistake.
No, not only mistake, but
little mistakes.
wow.
That was a time-consuming mistake.
Yeah.
But it wasn't a mistake because at the time you needed the literature,
Oh yeah.
so
Yeah.
it was worth it for a while.
It is.
Okay then. Well, you done for a while?
You are the.
You have anything else to say of importance? I have one question left to ask you. Have you decided that the oomycetes are not fungi?
No, they are fungi, damn it.
I hope you're saying fungi with a little F.
No, they are. No, look.
They act like fungi.
They are.
Yeah.
I'll tell you what the problem is. The problem is, look at the program. There's
Nothing.
practically nothing.
I know.
They have been ostracized from the society. This is a mistake.
You would think the plant pathologist would be studying them.
Yeah, well.
There's Phytophthora outbreaks all the time.
Plant pathologists are confused by this. They use fungicides. They're not going to use
Seedicides.
No, it is. It is a mistake, and you know what I loved was the fact that within the fungi we have two evolutionary lines, and they don't want to accept that you can have a kingdom with two evolutionary lines.
No.
Why do you have to have only one line? You can have two lines, because all the other properties, you can look at them, and structure and behavior, oomycetes. Some of the oomycetes are exactly like that.
Are there biochemical similarities, any of them, with
They are
fungi?
with differences, with nice differences, which makes it for interesting comparisons, because you can see that at one point, long time ago in evolution, fungi developed, but separately, the oomycetes developed. And each one solved the same problems, but with
Different
slightly
ways.
different chemistry, slightly different.
So it was
Like an amino acid is one amino acid is different. Okay, make the proteins with a different amino acids. That's one thing. I'm saying wrong. Make the same amino acid, but a different pathway.
right.
And this is what makes it very, very interesting. You compare also the cell walls; they're different. They're cellulosic, but cellulose and chitin are
Later
practically the same in physical properties. So why did they choose cellulose? Well, you know, and besides, the oomycetes evolved before the rest of the fungi. So they are the real fungi.
Okay.
You know, this is something, I don't know why they feel so upset about me saying that all my seeds are fungi. So I find, you know, some of them.
Well, I think they should continue to be studied by plant pathologists more.
Not plant pathologists, mycologists.
Yeah.
You have expelled them. You know, this is such nonsense to have expelled the oomycetes from this society.
What do you think when there's less emphasis on taxonomy and phylogeny, that maybe oomycetes will come back?
They never left. It's only in the minds of some misguided phylogeneticists that they put them aside. I mean, you know, people. You can say that there is a racist element in that. You know. Oh, it has to be pure. No, it's not pure. We don't want it. They have different ancestors.
Well,
No, it's because of what they are and how they behave that I think they make good subjects. Did you ever play with oomycetes?
a little bit, yeah.
They're-
In fact, one
I-
summer they killed off Azolla. I played with them all one summer. They killed Azolla within one day.
Oh yeah,
Yeah,
that's great.
yeah, it was It was Pythium.
Yeah.